Hi everyone, in Algebra 3 today we are going to be going over questions on lesson 75. And for this problem, we're going to start on number 16. It says write the equation of the sinusoid as a cosine function. So I have the graph right here, and I want this to become a cosine function. So what I'm going to start by doing is I'm going to list my A, or find my A, and then my B, and my C. And then at the same time, I can also show you what the phase shift is going to be D. So for A, we're going to look at the top point and the bottom point. So if you look here, the top point is 7, the bottom point is -1. So the midpoint between that would be 7 plus -1 divided by 2. Then if I'm going to find the amplitude, which would be the difference between that dotted line and the 7, so you're going to do 7 minus whatever you get for A. Then for C, we're going to find the length of the period, which is in degrees, so it's going to be 360 divided by the length of the period, which in this case, we can either calculate from peak to peak or base to base. So if you see that it's currently peaking at -90 and then peaks again at 450 degrees, the length of the period would be 90 degrees plus 450 degrees. And then lastly is the phase shift. What I'm going to note on the phase shift D is just where it's currently peaking. And it's currently peaking at -90 degrees, which is where I am going to put my phase shift at, which is -90 degrees. So phase shift -90. 7 plus -1 divided by 2 would be 6 divided by 2, which would be 3. Amplitude 7 minus 3, which is going to be equal to 4. Then 450 plus 90 is 540. So 360 divided by 540, written as a fraction, would be 2/3. And my phase shift is -90. So my equation for number 16 is going to be y is equal to 3 plus 4 cosine 2/3 x minus -90, because that's my phase shift, which is D. So my answer will just become y equals 3 plus 4 cosine 2/3 x plus 90 degrees. And that would be your result. So your phase shift was -90. 2 negatives make a positive. That's how you end up with x plus 90 for that one. And that's number 16. Now, moving on, we're going to look at number 17, which is write the equation of the sinusoid whose graph is a sine function with a center line of 10, an amplitude of 6, and a period of 4 pi and a phase angle of pi/2, which means that would be your D. So what they actually give us is they give us A for 17 is equal to 10. They give us B, the amplitude is equal to 6. They give us C, is 2 pi divided by the length of the period, which they give us the length of the period is 4 pi. And then D is the phase shift, which would be pi/2. Now this would simplify here. The pi's would cancel, and that would simplify to 1/2. We are writing this as a sine function. So this will turn into y is equal to A, 10, plus B, 6, sine C, which is 1/2, and then x minus the phase angle, which is pi/2. And that is number 17. Now looking at number 18, what we're going to do first is we have to take the two outside numbers and we're going to multiply them by each other. And then we're going to add the degrees together before expanding. So 5 times 2 on number 18 is going to give me 10 CIS. And then I'm going to do 660 minus 120, which would be 540. Because that's greater than 360, I'm going to subtract 360 from it, which would give me, when I expand it, 10 cosine of 180 plus I sine of 180. Now 180 degrees is going to use the unit circle, specifically pointing to the left, and that coordinate is -1, 0. Cosine is equal to the x coordinate, sine is equal to the y coordinate. So that would give me 10 times the cosine of 180 would be -1. The sine of 180 would be 0, I. And all you have to do is distribute the 10, and your result is just going to be -10. Because that would be -10 plus 0i. So you have to use the unit circle on that one, not a reference triangle. Now on to number 19, where we are going to start with A. So it's 5 plus 6i. Both of them are positive, meaning it's going to be in quadrant 1. It would be over 5 up 6. So 5, 6, angle, hypotenuse. We could do Pythagorean theorem to solve for the h, so it'd be 6 squared plus 5 squared. So 36 plus 25 equals 61. So h is going to be equal to the square root of 61. Our angle, we're going to use inverse tangent. And that's always opposite over adjacent, so 6 over 5. And in your calculator, you're going to do 6 divided by 5 equals, then second tangent. So your angle would be equal to 50.19. And because it's in quadrant 1, we don't actually have to change anything. So our answer is just going to be root 61 CIS 50.19 degrees. And that concludes A, but now we have to do B, which is to convert -7, -585 to rectangular form. So 585 negative plus 360 is going to be -225. So for B, I have -7 cosine of -225 plus I sine of -225. -225 means you're going to start going clockwise, starting in quadrant 4, and that would put you back in quadrant 2 with a 45-degree angle. So -1, 1 root 2. So I'm going to have -7 times the cosine, which would be -1 over root 2, but you can't leave the square root of 2 in the denominator. And then plus I sine, so that would be opposite over hypotenuse. So 1 over root 2. Can't leave the root 2 in the denominator. And you can't forget your I. And then you just distribute your -7, which is going to give you +7 root 2 over 2 minus 7 root 2 over 2i. And that's part B. Now looking at number 20, where we are going to be solving in degrees, not in radians. So I'm going to start by moving the 3 to the other side. So it'll be 4 sine squared theta equals 3. Then dividing by 4 and taking the square root. So that's going to give me sine theta equals plus or minus the square root of 3 over 2. So now we have to split that into two separate equations. I'm going to have sine theta equal to positive root 3 over 2. And then sine theta equals negative square root of 3 over 2. So I'm going to start with identifying where sine is positive. So I have all students take calculus. Everything is positive in quadrant 1, and sine is positive in quadrant 2. So opposite root 3, hypotenuse 2, root 3, 2, so that'll be 1 and negative 1. So for the first one, my answers are going to be 60 for quadrant 1, and then 120 for quadrant 2. Now for this one, I already know that sine is positive in quadrants 1 and 2, which means that's going to be negative in 3 and 4. So opposite hypotenuse, opposite hypotenuse. This angle is also 60 degrees. So in quadrant 3, I'm going to add it to 180, and that would be 240. And then in quadrant 4, I'm going to get 300. And that would be number 20. Now looking at number 21, I'm going to move the 1 to the other side, and then I'm going to divide by 2. So 21 would be sine theta over 3 equals 1/2. So I'm looking for where sine is positive again, and since I just did a problem similar, I know that it's positive in quadrant 1 and 2 because all students. It says 1/2, 1/2, and then that would be root 3 and negative root 3. So my first answer for theta over 3 is going to be equal to 30 degrees. My second answer for theta over 3 is going to be equal to 150 degrees because 180 minus 30 is 150. Now when I multiply both sides by 3, I get theta is equal to 90, and then theta is equal to 150 times 3, which is 450. But notice your parameters. They have to be less than 360 but greater than 0. 450 is not less than 360. So your only answer is going to be theta is equal to 90. Now looking at number 22, I have this equation here. So what I'm going to start by doing is changing all of the signs to, let's just do x. So I'm going to set x equal to sine theta. So that I can factor it. So that would be x squared minus 4x plus 3 equals 0. That factors evenly into x minus 3, x minus 1 equals 0. So I have two equations. I have x is equal to 3, and then I have x is equal to 1. I said that x is equal to sine. So this is going to be sine theta equals 3, and then sine theta equals 1. Now, for sine theta equal to 3, if I did opposite over hypotenuse, There is no triangle that's going to have an opposite of 3 and a hypotenuse of 1. So we do not have to solve for this one because it doesn't exist. Now I'm going to solve for where sine is equal to positive 1, and that's going to involve me using the unit circle. And remembering that on the unit circle, my sine is equal to the y coordinate. So if I underline all of my y coordinates, I notice that the y coordinate is equal to 1 only at 90 degrees, which means my answer is going to be theta is equal to 90. And that will be my only answer for number 22, is that theta is equal to 90. Now looking at this problem here, number 23, we have evaluate cotangent squared of 14 pi over 3 minus cosecant squared of 14 pi over 3 plus sine squared of 14 pi over 3 plus cosine squared of 14 pi over 3. I'm going to start by making my little snowflake chart for this one for over 3. So that would be 1, 2, 3, 1. Starting at 0 and then counting 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Puts me back in quadrant 2 with a 60-degree angle. So that would be negative 1, root 3, and 2. The cotangent of this triangle is going to be adjacent over opposite. So that's going to be negative 1 over root 3 squared minus cosecant is hypotenuse over opposite. So that would be 2 over root 3 squared. Sine is opposite over hypotenuse, so that's just going to be square root of 3 over 2. And cosine is adjacent over hypotenuse, so that would be negative 1 over 2 squared. This would be positive 1/3 minus, 4/3 plus 3 over 4, and then minus or plus 1 over 4. Square, or 1/2 squared is 1/4. 1/3 minus 4/3 would be negative 1, and then 3/4 plus 1/4 is positive 1. So my result is just 0 for number 23. Now for number 24, we're going to need to use our calculators for this one. We are looking for all of these things. So 24, I'm going to start with trying to find the median, the middle number, then the mode, then I'll do the mean and the standard deviation, and then lastly I'll do the variance. So I'm going to start with the median, which is the middle number. So 1, 2, between 0 and 3. What's between 0 and 3? Well, I would have to do 0 plus 3 divided by 2. That would be 1.5 would be my median. My mode is going to be 0 because that's the number that shows up the most. Now we have to use our calculator. So I'm going to do second 7. It says error. That means there is nothing stored in my calculator. Now I'm going to input my variables. So I'm going to start with negative 2, then 0, then 0, 3, 6, and 9. So I should have 6 variables plugged in. And now to find the mean, you're going to do second x squared, which gives me 2.67. For the standard deviation, I'm going to do second divide, which would be 3.82. Then for the variance, I'm just going to square what I got for the standard deviation. That would be 14.56. And those are going to be all my answers for number 24. And most of those just using your calculator. Now for number 25, we are going to be graphing. The first one's going to be a parabola. The second one is going to be a circle. So for number 25, I need a graph. I'm going to do 4 in every direction. Okay, so this first one is going to be at -4, and then over 1, up 1, over 2, up 4. So your graph should look like this. Now your second one is going to be a circle with a radius of 3 and centered at 0, 0. Okay. And now we're going to be diagramming or shading. So for this one, it says that we are going to shade everything below the parabola. So below the parabola would be basically everything outside of the parabola. So for that, it would be all of, this. Now for the circle, when it says less than the radius, that's everything inside of the circle. So your answer is going to be this small section outside of the parabola, but inside of the circle. And if it's a little hard to see, there. So it's the section inside of the circle and outside of the parabola. That would be your answer for number 25. Now for number 26, we get to find the distance between a point and the line, which is probably your favorite problem at this point. They already give you the line, which is great. So now all we have to do is we need to find the perpendicular of that line, which would be -1/3 x plus b. I'm going to plug in the point 1, 1, so that would be 1 equals -1/3 times 1 plus b. So that would be 3/3 plus 1/3 equals b. So that means my perpendicular line is going to be y equals -1/3 x plus 4/3. Step 2 is going to be to find where these two lines intersect. So I'm going to set the original line, 3x plus 2, equal to my perpendicular line. And to get rid of the fraction, I'm going to multiply this whole thing by 3. So that would be 9x plus 6 is equal to -x plus 4. So that would be 10x equals -2. So x would be -1/5. And then for step 3, we're going to solve for y. So you can plug this into either your original line or to your perpendicular line. It doesn't matter which one. So 3 times -1/5 plus 2. Common denominator. So -3 plus 10 would be 7/5. And now our final step is to find the distance between my original point and this point of intersection. So the distance is going to be equal to the square root of 1 minus -1/5, which would turn into 1 plus 1/5 squared, plus 1 minus 7/5 squared. So that's going to turn into 6/5 squared plus -2/5 squared. Which would be 36 plus 4/25. which would be the square root of 40 over 25. And the square root of 40, we can simplify to 2 square root 10 over 5. That should be the square root of 25. And that's your oh wow, you didn't even see that. And that is going to be your result for number 26. I'm sorry, I kind of cut off that bottom of it. I'll leave it up there for a second. So just simplifying all of that, it's a very tedious process, obviously. And now we're going to move on to number 27. So we see there's a number outside my logarithm, which is going to become the exponent. So for number 27, I am going to get ln of 8 to the 1/3 plus ln x squared equals ln negative 3x plus 2. We are going to multiply these two to combine them. So that would be ln of 2x squared equals ln of negative 3x plus 2. Get rid of the ln by raising it to the base, which is e. And I'm going to set this equal to 0. So that would be 2x squared minus 3x minus 2 equals 0. We do have to solve for x, so I'm going to do quadratic formula. X equals negative 3 plus or minus the square root. Negative 3 squared minus 4 times a times c all over 2 times a. So that would be positive 3 over 4 plus or minus the square root of 9 plus 16. The square root of 9 plus 16 is the square root of 25. So that would be 3 over 4 plus or minus 5 over 4. So my two answers are going to be x is equal to 3 plus 5, which is 8 over 4, and that's 2. Or 3 minus 5, which would be negative 2 over 4, and that would be negative 1/2. But remember that you can never take the log of a negative number. So if you plugged in that negative 1/2, it would be ln of negative 1/2. You can never take the log of a negative or the natural log of a negative. So your only answer is going to be x is equal to 2. Now looking at number 28, we do have 3 parts to this problem. So I'm going to take a little bit of space, but there's a number outside my logarithm here, which is going to become the exponent. So for number 28, I'm going to have h to the power of, log h2 to the 3rd minus log h2 minus log h6. 2 to the 3rd is 8, but then combining minus would be to divide. So that would be h to the log h of 8 over 2 minus log h of 6. Now their minus sign means we divide, so that would be h to the log h of 4 divided by 6. The h and the log h will now cancel, so your answer is going to be 2/3 for A. For B, I have a number outside my logarithm, so those are going to become the, end up multiplying by the current exponents. So that would be log 10 to the 3rd to the 5th plus log 10 to the 1/2 to the 2nd, minus ln e to the 2nd. So we do multiply those numbers together, so that would be log 10 to the 15th plus log 10 to the 1 minus ln e to the 2. Now the log and the 10, log 10 and ln and e cancel. So we have 15 plus 1 minus 2 equals 14. And then lastly, we're going to look at C, which is going to be kind of similar to the last one because we have log 10 to the 1/2 plus ln e to the 3/2 minus that should be ln e to the 1/3 to the power of 6. So we multiply the 1/3 and the 6. Everything else is going to stay the same. Log 10 to the 1/2 plus ln e to the 3/2 minus ln e to the 2, because 1/3 times 6 is 2. The log and the 10, the ln and the e cancel, so I have 1/2 plus 3/2 minus 2. So that would be 4 over 2, which is 2. 2 minus 2 is just 0. Number 29 is just going to require you to have a calculator with you. So for 29a, all we're doing is we're evaluating 6 to the power of -2. So 6 to the power of -2 would be 0.0278. And for B, we are just evaluating 2 to the power of -6, which would be 0.0156. And that is it. So anti-log just means you're solving for the number, not for the, you're solving for the number, not for the exponent, which we do with log. Now, lastly, we're going to be looking at number 30, which is to factor over the set of complex numbers. What I need to do first is I need to solve for the roots of this equation, so then I am able to solve or plug it into the x minus root times x minus root equals 0 equation. So for number 30, I'm going to start with solving for the roots, which would be x is equal to -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So I'm going to get 5 over 2 plus or minus the square root of 25 minus 48 over 4. So that's going to be 5 over 2 plus or minus the square root of 23i over 4. Should be 5 over 4, not 2. And these are going to be your roots. So when you plug it into x minus root times x minus root, the signs are going to change. So it's going to change from positive 5 over 4 to negative 5 over 4. The positive root 23 changes to negative root 23 over 4. And then again, 5 over 4 changes to negative 5 over 4. And then negative root 23 changes to positive root 23 over 4i. And that is what it means when it says to factor over the set of complex numbers. That should conclude all of your questions from this lesson 75. I hope you guys all have a great day. Bye.